Hi everyone, so I'm going to show you nonlinear curve fitting with MATLAB, and as an example I'm going to show you a logistic function function which actually looks like this. So y equals to y is a function of x, so this is our controlled variable and this is the uncontrolled variable, and this function takes two other parameters, k and L. And how does it look like? It is something like this: y equals L over 1 plus e to the power minus k times x. So x is our controlled variable, y is our uncontrolled variable, and these are the two unknowns, L and k, that we need to find to make a curve fitting. Okay, so we are going to look for the best L and k which fits a data with the logistic function. Okay, so as I said, the logistic function looks something like this: L 1 plus e to the power minus kx. So you can apply whatever we are doing today in this video with any nonlinear function, but as an example, this is the nonlinear function that we are going to use. That is a logistic function. So let's see how it looks like. So in MATLAB we have already a data here. You don't need to worry about it. So I'm just going to show you what a logistic function looks like. Okay, so this is our x. Here in this example, x takes the values between -4 to +4, and the y values corresponding to these x values are from 0 to 5. So here L basically determines the maximum value of the logistic function, and k here determines the steepness of this curve. Okay, so if we are given a data which doesn't look like a perfect logistic function, but something like this. In this case, the data is scattered around again, -4 to 4, but it is not evident that we should use a logistic function. Maybe a linear fit is also a good choice, but here in this example we are going to find the best logistic function which explains this data. Okay, so it is sort of a nice data because you see it starts around somewhere 0, it saturates at some values, and in between there is a change from the low values to the high values. So the logistic function can actually be a good candidate. And what we are going to do with curve fitting is basically finding the parameters, then finding the error, so that we can have a quantitative idea about whether this logistic function is a good fit or not. So one problem about finding the best parameters is that we don't know which range we should search for, okay, for L and K. So how can we do this easily? We can just try some numbers. So let's have a look here when the x is about 4. Okay, so here we can take the value x4, and let's take k equals 1, and for this case let's see what logical values we can select for L. Okay, so y is equal to L over 1 plus, so e to the power -4. Okay, so this is a very small number. So this is something really close to 0. So that means whatever y we see here is actually something very similar to the value of L. Okay, so here then we can take the L is something around 5. Okay, if we take k equal 1 and L equals to 5, that's a good range to search for. So we can check this range with the negative limit. So when x is minus 4, then this one becomes a very large number. Then whatever L you take, then y will be 0. So L shouldn't be a very large number. As long as it is around the values 5 or something like that, it satisfies the relationship that when x is minus 4, this is then a very big number, so y equals 0. That is okay, looking at this graph. So let's write the code to find this logistic function. I'm going to take my figure here. So this is how I started. I started by loading the data and plotting the dots to see how my data looks like. And the next thing I'm going to do is I have to define the ranges for the function parameters L. So for L, I define a variable called LRange. As we decided, it takes values about 5. Okay, so let's search from 0 to 10 with steps of 0.1. Okay, so we should at first choose our range to be relatively large in comparison to the range that we have a guess. Okay, so for k, we should also get a range to start. So we said k can take values around 1. So why don't we then choose a searching area again between 0 and 5. Okay,